Welcome in our booth here, Transparency and Speed. It stands for the battery manufacturing. And important is what we understand, how we drive the digitalization forward. And I want to show you some steps how we're going to make that. So from the beginning, so our journey starts here. If you want to follow me, you can see there the entire process. I want to show it to you step by step. First of all, how you can gain speed in the battery manufacturing. So there's a big demand for battery cells. I think maybe you have also an electrical car, and there's a big demand to produce new cells. And the leverage or how you can gain speed is to have the digital modeling, all designed in the virtual world, and that brings you real advantages. So what you can see here is the digital modeling of our cells. So it depends on what kind of cells you want to produce, round cells, prismatic cells, and all these cells are designed, tested, and validated in the virtual world. So that means we have one digital twin, the digital twin of the product. And if you follow me to the next station, it's very important also, when everything is validated, we're handing over the data to the digital production. So again, nothing is built, so you're saving a lot of money. You're doing the commissioning, the virtual commissioning, the testing, everything in the virtual world, and this gives you at the end a real advantage. And then you can start the real production. We're handing over the data to, let's follow me, to the real world. That means our controllers, our drives are coming into play. We have also our service portfolio that is supporting you in the entire process of the battery manufacturing. And maybe you're asking yourself, okay, answered speed, transparency, it stands for how can I get transparency in my production line? So there we have our edge systems. They are uploading the data into the cloud or in a local computer. And then in the end, we have intelligent apps who helps you out to make predictive maintenance or analysis. So, as you see there, a lot of people are joining our booth today. And I saw there a very nice fair model. And here is my good friend, Mark. Hey, nice to meet you. And let's give us the insights from that machine, okay?
Yeah, within 4 minutes, okay. Welcome in the digital and partly also real world of battery production. So you see here one of the key process, the stacking process. Of course, this is not a real machine, it's a demonstrator, because the real machine would need more space. And if you imagine 60 stacking machines within a gigafactory would even need a whole fairground. But what we want to show is here how speed and transparency meet stacking challenges. So all these use cases, of course, can be transferred to a real machine. And the touch point of this machine development was the process idea of the KIT, so the Karlsruhe Institute. They wanted to reduce the scrap rate within the battery production. They wanted to increase the performance of the machine, reducing the access, the synchronized access, and they wanted to have a flexibility within the battery production. So you can here produce from a coil, here on the left side, to the end product, a stack with different sizes, with different lengths, with different sizes. And nearly with zero investment. This was a challenge we have to meet. And this was the point where Siemens comes in. So Siemens started with the machine development on a virtual base. So to have validated machine concepts, mechanic, static, and of course, to simulate the whole processes with movements like the gripping function or the wheel winding. Furthermore, the hardware, this is well known from Siemens, so you see it here in the cabinet, have been reduced due to the fact that the decentralized periphery was exactly installed where it is used, here on the wheel. Furthermore, the code was programmed and generated. So means we have a basic code where we can use future-proofed libraries of battery for conveying, cutting, and accurate position. And finally, at the end, the virtual commissioning of this machine has been done on-site in the campus of the KIT, and that reduced 50% FAT already in the virtual environment. This, of course, was a stressless, real commissioning on-site. Okay, we have still a couple of seconds. Christine, 1 minute. Okay, because I want to show you and want to announce the first reference with the digital twin with our customer, Mans. Mans has used this digital twin environment to speed up their new laser tap welding machine. With the integrated battery guideline functionalities, where everything was predefined, they have reached less engineering of 20%. When you want to see something regarding that reference, just take a look on our Siemens.com battery site and enjoy in a really smooth environment.